Good morning, everyone. Thank you for joining us for our Friends with FieldView series. This morning we have our folks from Croptimistic here to show us how FieldView integrates with their platform. Before we get to the main stage of events, let's take care of a little bit of housekeeping. First off, we want you to be able to ask your questions, and so the two ways that you can do that are either in the chat or using the Q&A box. If you don't see either of those on the right-hand side of your screen, use the controls at the bottom center of your screen to pull up either the chat or the question and answer box. Either way, I'll be watching those and I will get your questions presented to our expert guest here this morning. Our next bit of housekeeping is a check-in with our legal team, and they just want us to remind you that the Friends with FieldView webinars are for informational purposes only. The Climate Corporation has not vetted and does not endorse any claims made by third parties. So now that we have all that out of the way, Scott, I'm going to turn things over to you to introduce our guest this morning.
Sounds great. Thanks so much. And good morning, everyone. Thanks for joining us for our Friends with FieldView series. My name is Scott Speck. I'm an activation manager here at the Climate Corporation. On the climate team, I'm also joined today by Mindy McDermott, who is our learning and development specialist. This morning, we're joined by Jack Seitz, VP of Sales for Croptimistic, who will be our main presenter. On the call, we're also joined by Corey Wilness, the president and founder of Croptimistic, as well as Trevor Friesen, the SWOT technology specialist at Croptimistic, for questions. The goal of our Friends with FieldView series is to provide general awareness of the platform partners that are integrated with climate, both internally and to our customers and dealers of Climate FieldView, while providing an opportunity to learn more about the partners' products, the support and field teams that are available, as well as the offers and opportunities that you'll hear about at the end of the presentation today. Today, we have our friends from Croptimistic and SWATmaps on to discuss soil mapping layers and opportunities for management decisions. If you don't know about them, Croptimistic is probably best known for their soil mapping technologies through their patented SWOTmaps and SWOT Box collection device. The organization also integrates data to and from FieldView through their SWOT record software that you'll see here this morning. Thanks again for joining us, and please ask questions as we go along. Now I'll pass it over to our friends from Croptimistic. Jack, it is all yours. Thanks for joining us.
Good morning, folks, and thank you for the opportunity to present to you this morning. My name is Jack Seitz, and today we're going to just have a general overview of our SWOT maps, which we view as an ecosystem of crop management. So a little bit about myself. Currently, I live right near Loveland, Colorado, where I have since 2007. I did grow up on a mixed farm just outside of Regina, Saskatchewan. I'm a U of S alumni, and I'm an agronomist by trade. I've had a great 33-year career in ag tech sales. My last post was a 2-year position with IBM. And then I joined Croptimistic just last October, and I'm super excited about the SWOT map technology and the value that it brings to agriculture. Just a little short history about our company. SWOTmaps originated in 2008. It was founded by Corey Wilness and Shannon Wilness and Derek Massey, who are current owners of the company. And Croptimistic owns the patents on our SWOTmaps products, our SWOT water maps, and the SWOT Box, which we'll go over in a bit here. Our head office is in Nacum, Saskatchewan, and we currently have a global network of about 100 partners. Our mission statement: what we want to do is provide the world's leading soil-based zone management system to all of our clients around the world for variable rate fertilizer, seed, and irrigation applications. So let's talk about what we view as the undeniable world. Agriculture is changing, and so is our need to innovate. It's really hard to make an argument that the old ways are sustainable and maximize our efficiency. So the undeniable world is that we need to produce more food with less resources. I've been all over this planet, and farmers all over the world face razor-sharp margins, and everywhere they need technology to help them produce more with less and increase their bottom line, all the while preserving the land with sustainable farming practices. Now, the old world The old world has us managing the field as a single flat rate of seed and fertilizer. But we all know there's plenty of variability, so it doesn't make sense to manage it that way. There seems to be no great way to capture data, and there seems to be no feedback mechanism, so there's little room for improvement. The new reality, the one which I believe climate also participates in, is that modern day technology and tools now allow us to capture that data. And not only can we capture it, but we can capture it spatially. And we can maximize the use of seed, fertilizer, water, and other soil applied amendments in a far more efficient manner. I think we could all agree that one of the biggest expenses that farmers are faced with managing is their fertilizer, seed, and soil-based pesticides and water. These are really expensive inputs. And using these inputs in a more efficient manner only makes sense. So why not start there? So what's at stake? Well, from our opinion is that the viability of the primary producer is at stake. And those that are adapting and changing are winning. They're winning in the market. And those are not risk losing everything and accept extinction. So what's our solution to the new reality? Well, we see it as variable rate inputs. And the simple goal of variable rate technology is to do a better job of applying the right rate in the right zone of the field. In order to do that, there's two key fundamentals that we have to observe. Firstly, we have to get the zone maps right. One way to look at this is that you have many smaller fields within a larger field, and you need to get the right rate on all those smaller fields. And if you're managing with that mindset, you need to find a way to group those areas together, ones that respond the same, and put them onto one map. And this piece is very critical in terms of getting it right the first time. The second piece is that once you have the right areas grouped onto one map, you need to determine the optimal fertility or seed rate for those like areas in order to optimize the return on the dollars you spend. So I want to introduce you to zone maps that we call SWOT maps. SWOT maps are a patented zone-based soil fertility potential map. And they're created using various layers of data, but they're heavily weighted towards electrical conductivity, elevation, and topography. So let's talk about those layers a little bit. Electrical conductivity alone is a useful layer, but it's not sufficient as a single layer. And the reason it's not sufficient is because it's not a measurement of any one specific thing. Electrical conductivity is affected by soil moisture, soil texture, dissolved solutes, even salinity changes those values in the field. So it's a useful layer, but it's not one specific thing, and it can't be used alone to create soil zones. Now, elevation data, also useful, is required to understand the water flows. The fundamental principle to soil development across any structure is the movement of water. More important than the elevation data itself is the topography. The topography is derived from the elevation data, and it's critical to understand the landscape position. So where are the knolls? Where are the mid-slopes? Where are the depressions? Now, if you combine all three of these layers together, you can build a SWOT map. And SWOT, soil, water, and topography, is a soil zone fertility potential map. Let's talk about that in a little more depth. Here's an example of a typical field in Western Canada. And in this field, you've got areas that are shedding water, and you've got areas that are collecting water. Now, in a SWOT map, we will create 10 of these zones in every field. Typically, the high and dry areas, like you see right here, are zones 1 and 2. And typically, the water collecting areas that are very low in topography are zones 9 and 10. And then we kind of have a scale of everything in between. So every field that's SWOT mapped has 10 zones created in it. Why 10 zones? Well, the answer is that every field contains areas that are water shedding, and every field contains areas that are water collecting. And the areas that shed the water start at the top from a zone standpoint and are represented again by zones 1 and 2. The areas that collect water are at the bottom of the scale, typically 9 and 10. And we found over time that 10 zones represents a nice balance between enough resolution to manage this field in an efficient way and practicality. So let's have a look at these zones again. In this field, you have zone 1 and 2. Zone 1 and 2 would be eroded knolls, hills, typically sandy textures, lower organic matter, and the driest areas of the field. As we move down the slopes, we get to the shoulder slopes. That would be zones 3 and 4. So this is the upper part of the watershed, but water runs off of these slopes. Zones 5 and 6 would be our mid-slopes. They would be flat areas in the field, maybe something you would call average field topography. Zone 7 and 8 we call the toe slopes. So these are the lower flats, starting to collect a little water, but still shedding it. And then zones 9 and 10, the depressions, the saline areas, the high clay content, water collection, high organic matter, and typically wet parts of the field. So one way to think of soil, water, and topography maps is to think of them as an index of how to group areas of the field together that respond in a similar way to fertilizer. The groupings are common to all fields and in general will behave similarly to fertilizer, but sampling is required in each zone in order to determine the absolute fertility levels in each zone and in every field. The results of the soil samples combined with local agronomy then drive the fertility recommendations by zone. So a common question we get are the zones consistent on each map with the legend? And the answer is yes. Each map will always have a legend of 10 zones for every field. But a zone 1 in field 1 is not necessarily the same as a zone 1 in field 2. And that's why we require soil sampling in those zones for every field to determine the absolute values of the zone. But the zones are consistent on each map with the legend. So why not use National Soil Sample Survey data to create field zones? Well, national soil surveys don't exist everywhere, but when they do, there's a simple answer. While they're better than nothing, they lack the resolution and the precision required to properly create field fertility response zones. And in this example, you can see a field that I mapped last fall in the Midwest US, and we overlaid the Shishirgo soil sample zone data. Now you can see the variability that exists within the Shishirgo soil zones. You can see it in several spots on this map. So if I look at this zone right here, in this zone we've got high and dry areas, and right next to it we've got lower, wetter areas. This zone right here is a huge soil zone. And within this zone, we have our deepest water collecting areas and high sandy knolls. So it doesn't make sense to manage the field this way when there's variability within the soil zones that are on the Shishirgo map. Okay, so we can't use national soil surveys. What about grid sampling? Grid sampling's been around for years, and in many places, it's a de facto status quo to determine soil zones in a field. So what's wrong with grid samples? Well, there isn't anything wrong with grid samples. They certainly give a lot more resolution to the field soil zones than the national surveys. But in our opinion, they still lack the resolution required to create high resolution field soil zones. So take this field, for example, that you can see here. It's relatively small. It's only about 40 acres in size and has relatively flat topography. Now, if we choose to sample this field, where do we place the sample points? Do we place them randomly within each grid? Do we center them in the grid? It's really just a judgment call. Now, if we take a SWOT map and overlay it onto this field, you can see how the results would look. Can you see anything in this map that would raise some red flags? Let's have a closer look at one of the zones in the northeast corner of this field. Now, within that zone, we actually have several different SWOT maps. And those maps actually show us higher and drier and water shedding zones, plus the lower, wetter, and collecting zones, even within a 2.5 acre grid. So it doesn't make sense to treat these zones the same way with respect to fertility, because they have a different response to fertilizer. And if we came back later in the season and did some scouting in this field, it would be pretty easy to spot the variability on how these zones respond to a single fertility rate. Now, if we think of a typical spreader going across this field with a width of, let's say, 60 or 70 feet, there's still plenty of resolution in the application equipment to take advantage and manage these zones properly. But the limiting factor is the zone size. And if we reduce the zone size to, say, a 1 acre grid to try and gain more resolution through the grid sampling process, well, then sampling just becomes too expensive and it's not feasible anymore. So what about the soil sampling? After we've collected the appropriate data and created the SWOT maps, and we've gone out to the field and ground truthed and verified that that SWOT map matches the soil structures of the field, then we need to soil sample the individual zones to understand the absolute fertility levels within each zone. Now, our SWOT record software has a mobile application, and we'll cover it a little bit more in a few more slides here. But this mobile application can create suggested sampling points. And typically at Croptimistic, we'll group 2 zones into a unique composite sample. So on this map, you can see we've kind of grouped zones 1 and 2 into a sample, and zones 3 and 4, 5 and 6, 7 and 8, 9 and 10. So we're going to take 5 composite samples in this field from various locations, maybe 3 to 4 cores at each sample site, fill a bag full of soil, and we'll have a very nice resolution and practicality on the soil sampling side. And of course, there's always provisions for the independent agronomist to sample at a higher resolution if they deem necessary. The soil sample results are then integrated automatically into our SWOT record software via APIs, so the agronomist can send off the samples, have the lab analyze them, the data automatically uploads to our SWOT records, and that's where the agronomist can create a variable rate plant nutrition plan for the farmer and output that to a controller with a script for a wide variety of popular controllers. So let's kind of go over a summary of the process. How do we do this? We take our mapping device, SWOT Box, and I'll cover that shortly. SWOT Box will collect the field data. 2 key layers we need to collect: electrical conductivity and high accuracy elevation data. That can come from either RTK GPS or LiDAR when available. That data is automatically streamed to our SWOT record server, where our professional map developers create the SWOT maps. And actually, for every field that we do create SWOT maps, we create around 10 different versions, upwards of 15 for every field. And at that point, the agronomist is going to go to the field and ground truth the field and decide which versions of the SWOT maps are the most ideal fit to the actual soil structures in the field. That becomes the fundamental starting point for the process. That becomes the SWOT map. Once we have that SWOT map, you can create the sampling points, go to the field with your mobile application, pull the cores from the suggested locations, send those off to the soil sample lab. The results are integrated into our SWOT records software, where you can create the fertility plan for the grower and output a script to a variable rate controller, help the farmer upload it to his controller, and away he goes doing variable rate fertility on his field. That's the high level process of how the SWOT map system works. Let's talk about the SWOT box. So the SWOT box is our patented self-contained soil mapping system, and we think it's the best one on the planet. It's completely autonomous, so the data collection is very easy. It's very simple to operate. It has a local Bluetooth connection, so you can operate it just with your smartphone or tablet, which creates a very nice in-vehicle dashboard. All you do is add the client farm information so that the data can be sorted out by our map developers, and it's directly transmitted to our SWOT records accounts. It provides real-time view of that data for quality control. There you get some real-time feedback on sensor status. Because of the connectivity of the device, we have remote support and troubleshooting. And more or less, you just plug it into power and start driving a parallel swath across the field, and the data will be gathered and streamed directly to the SWOT record server. There's some simple training videos that we supply to do this process through our SWOT Academy, and away you go mapping. The device is very easy to pin up on the back of the vehicle. There's just a couple of pins and it folds up for transport off to the next field. Very fast. It's very high capacity. You can average about 100 acres an hour with this device, so you can cover some ground pretty quickly. We recommend an 80-foot swath path and a maximum speed of 35 miles an hour. This gives us enough resolution to create the SWOT maps, enough data points in the field. The nice thing about the SWOT box is that it streams the data and integrates seamlessly with SWOT records. So there's no files to handle, there's no USB sticks or anything like that. It's automatically uploaded to SWOT records, where the data is then processed automatically by our map developers. The map developers will clip the data to the boundary of the field. That will give nice seamless operation of variable rate equipment. The data is auto-filtered for errors, and the sensor also has a really large data buffer in it, so you never have data loss. It's got an internal battery for backup in case there's a power loss. All the data is always saved internally. Even if you are not in an area of cell coverage, you can still operate the SWOT box, collect the data. The data is stored internally, and then as soon as you get back into wireless data signal, it's automatically synchronized back to SWOT records. Now, I will take a second and say that we can use electrical conductivity from virtually any EC sensor if it's good quality data, including EM38s, dual EMs, the topsoil mapper, or even Veris. We simply import those records into those raw data files into SWOT records, create the SWOT maps. But if you won't be able to take advantage of all the simplified mapping features of SWOT box, but it is possible. The other thing about the SWOT box is It's pretty universally mountable. So you can mount it to maybe 75% of farm equipment quite easily. We have growers that pull them behind their liquid carts. A very popular option is to mount the SWOT Box onto a UTV or a side-by-side. We've done it on sprayer booms and tillage bars, so it's got flexible mounting options.
Perfect. Thank you, Jack. And thanks for bailing me out earlier on the question. I was having some technical difficulties. But question here for you, given all this information, how often is a SWOT map collected?
Well, the SWOT map represents permanent soil structures in the field. So unless those structures are changing dramatically from year to year, like physically the owner of the field is changing the landscape or tile draining the field or moving waterways, the SWOT map is only collected once for the field. We consider it kind of a permanent digital asset for the field, and it doesn't change much from year to year. So the SWOT map is collected once for every field.
Perfect. Okay, and then another question that's come in here, how does the zones, the 10 zones, how do the 10 zones that you map a field to, how does that work with a field where there are big differences in the topography?
Well, let's just think about it as a grouping of areas of similar soil fertility response in the field into 10 different groups, and then putting those on one map. So the system works in fields that have wide changes in topography, as well as fields that to the eye look virtually flat. All those fields will have water shedding and water collecting zones, and we group them the same way. So, we have over a decade of experience doing this, and all those fields have been SWOT mapped, or examples of those fields have been SWOT mapped, and the 10 zone serves them fine, even if you have large swings in topography.
Perfect, thank you. That is all for questions for right now.
Okay, then let's move on and just have a quick overview of the SWOT Records software platform. SWOT Records is like the hub of our system. It's where all the data is always collected and where all the data is always synchronized back out to the users of the platform. It comes in two versions, of course, desktop and mobile. Most people really use the mobile version. They really like it. It's a crop field database. So it's web-based. It has a sync function that supports multiple users. The data is very secure. It has farm logistics management capabilities, of course, soil and tissue sampling logistics. There's a scouting module included. Naturally, there's a variable rate module with a 3D map viewer. We also have a SWOT water module, which I'll talk about in a second. And really, this is where the API connection happens between our partners, which would include John Deere Operations Center and Climate FieldView. SWOT Records is free for all of our farmer growers to use, and it's a great way for our partners and consultants to link the data that they're creating for their clients directly with the farmers. Of course, that naturally happens mostly through the mobile app. The mobile app is really easy and fast to use with pick lists, and it works offline. So if you're out there in the field and you're doing some scouting using the mobile app and you don't have connectivity, no problem. The data is saved locally and then synchronized later when you reconnect. So let's talk about SWOT Water. SWOT Water is brand new for us in 2021. This is a feature that we've been working on for a couple of years, and it's included with our SWOT Records at no additional fee. SWOT Water maps are delivered weekly to our clients that are using them, and they're an extremely important management tool. I don't think anybody would disagree that water drives virtually everything in the field, from germination to nutrition, biology, disease, of course, yield, all driven by water in the field. So the way the SWOT water maps work, and I'll give you an overview of it in a second, but basically we start with the foundational SWOT map, and then we combine that with the soil moisture probe data, and we're able to model the plant available water across all the zones in the field. It's very useful as an in-season management tool. So while the SWOT map tends to be something that's very proactive and something you'll use to create fertility plans before planting, SWOT water maps can be used in season to manage variable rate top dressing decisions, fungicide decisions, variable rate irrigation application decisions. So it's a way to quickly understand by field zone the days of available water to the plant to make management decisions. So let's just have a little high-level look at how the SWOT water maps are created. We take the SWOT map, which is the foundation for everything. We understand by zone the soil textures. Then we add in a soil moisture probe in one zone of the field, typically kind of a mid-slope type zone. And through a direct API with that soil moisture probe, we're able to combine that data to model the water across all the zones in the field and create the SWOT water map. And those are updated weekly for our clients. From that information, we're able to do in-season management of nitrogen or fungicides, and even create variable rate irrigation scripts, or just give us some information to make decisions on when to irrigate. It's a great tool for in-season crop management. Okay, just a glimpse at something new that's coming here to Croptimistic. We call it the SWOT CAM. So the SWOT CAM is a low-cost image sensor that we would attach to a piece of application equipment. And as the equipment travels across the field doing normal application equipment functions, we would be capturing images of the field, thousands of images. And these images are all high definition. So what are we going to do with those? Well, with those images and our proprietary machine learning algorithms, we're able to create weed density maps by zone and crop density maps by zone. And these can be really important for variable rate herbicide. They're also important feedback loops to understand how the zones react and the mortality rates of the crop for future variable rate seeding scripts. So that's coming new in 2021, maybe early 2022. And all this data will be automatically synchronized back to SWOT Records, our central data hub. All right, let's talk about some differences, some unique things about SWOT maps versus maybe some other maps that are used in precision agriculture. SWOT maps are soil potential maps. We create them using soil sensors and high accuracy elevation data. They're very stable. So the properties of these zones really don't change from year to year. They're virtually permanent. The SWOT maps process includes local soil sampling by zone, so we can determine the absolute fertility of those zones and create fertility plans based off that information. Now, it's very useful for applying inputs into the soil. SWOT maps are spatial in nature. and they're a very proactive tool to use, prior to the planting season. Now, biomass and yield maps, also useful tools in precision agriculture. Usually they're collected using some sort of imaging device. Could be a satellite image, could be a drone, could be a camera, as we just talked about. Now, these images, while useful, they change. And usually with weather. Usually weather is what changes them. But they change from month to month, season to season, year to year. So they're very good at identifying crop health, maybe understanding some chlorophyll levels or disease, insect impacts on the field. But they're kind of a reactive tool. They only identify that once it's happened. They're also temporal in nature. And therefore, they're not really all that effective for creating soil zones because they change over time. All right. Couple last words here about SWOT maps. So we're at the point in the presentation where you say, all right, the maps look great, but what do I do with them? How do I use them? Well, the answer is that SWOT maps aren't just a map. It's a system of crop management. It's an ecosystem of tools for the entire season of agronomy. And in this slide, I'll walk you through some examples through an entire growing season for soybeans on how you can use SWOT maps and how they can be applied throughout the season. So we start out the season with the data collection. And the SWOT mapping process is typically done just once for a field that has never been SWOT mapped before. So we're going to scan the field, collect the electrical conductivity data, collect the high accuracy elevation data. We're going to create the zones in the field, and we're going to sample those zones. And once we have the absolute fertility levels of those zones established, we can write the fertility plan. Next step, create the controller scripts and upload them to the controllers so that the growers can go out there and apply the fertilizer or seed per the agronomist recommendation. After planting, we'll go and do some plant counts. So this is a great way to kind of understand early on in the season how the variable rate fertility and planting scripts are working. The purpose of the plant stand counts is really to determine the variability in emergence, and that becomes a useful piece of information for subsequent production years. Now, during the course of the season, we can also apply information from SWOT maps to the SWOT water maps if we are irrigating, and this will help us with variable rate irrigation or just irrigation decisions in general. We can also use the SWOT water maps for nitrogen or fungicide in season. So just prior to harvest, we'll go out to the field and do a final check, determine how our yield response is. Hopefully we've created some checkpoints in the field and we're comparing those to the zone yield response. And then lastly, we come to harvest time, where we're able to collect the yield data and, more importantly, understand it by zone. Okay, so that's an example of how you'd use this across the entire growing season. And all this data is gathered into SWOT records where it's collected and synthesized and used for feedback into next year's growing plans. All right, so let's summarize about SWOT maps. Why SWOT maps? Why would you use SWOT maps? Well, the first reason is that SWOT maps are a static layer. They don't change from year to year. They provide an excellent model for mobile nutrients and seed in the soil, and they are a great tool for big picture macro and micronutrients. The second reason, SWOTmaps are more than just a great map. Okay, it's a systematic process, a system of crop management. It's very reliable and very repeatable. And it provides an ecosystem, a feedback loop to make incremental improvements from year to year. Thirdly, SWOTmaps gets the zones right the first time. It reduces soil sampling costs versus traditional grid sampling. It gives a higher resolution compared to traditional type grid sampling. And through the process of ground truthing, it verifies that the zone map is right. And lastly, SWOTmaps has a great cost-benefit ratio. It works in all cropping environments where soil is used, and it has a significant upside revenue for the dollars invested. 4 great reasons on why SWOTmaps. All right, let's talk quickly about our FieldView integration. So we started our partnership in 2019 and signed up with the folks at Climate at that time around July 2019. And our beta version was launched just this past November, and our full release happened just in January. So this is a fresh integration. Now, the cool thing is that this is a two-way integration with FieldView. So we are able to push images of our SWOT maps into FieldView, where you can view them on that platform. And conversely, we can pull application data. FieldView is a great hub for data collection. So we can pull that application data from planters or sprayers and even yield data that's in FieldView into our SWOT records. The integration is very simple. It's just a matter of logging into accounts with usernames and passwords. And now we have a way for our mutual clients to really take advantage of the strengths of both platforms. It allows them to collect various maps and data related to soils. It allows them to collect application data, to have imagery, including things like NDVI. And it allows them to create scouting and yield maps. So it's really a great way for our mutual clients to take advantage of the strengths of both platforms.
Perfect. Thank you, Jack. You covered several of the layers that are shared between FieldView and SWOT records. And also, where can FieldView users find those maps in FieldView? And Scott, if you need to weigh in, Jack can address this first, and then Scott, you can add your 2 cents.
Yeah, the layers that we share between the two platforms, well, the SWOT map is the layer that Croptimistic shares with the FieldView platform. So that image can be viewable inside the FieldView platform. The information that we can receive from FieldView is the application data. So that would be planter and sprayer application data and yield maps. So that's the two-way layers. Now, I'm not a FieldView user, so Scott, maybe you can help our participants today to understand where they can find these maps in the FieldView platform.
Sure, absolutely. Yeah, to find any of those integrated layers that would come over from SWOT records, you'd find those in your imagery and then under other imagery. So they'll come in as those picture files that then you can overlay with any other map layers that you do have inside of FieldView.
Perfect. We will hold on any more questions for a couple more slides from you, Jack, and then we'll address more questions.
Yep, we're coming to the end here, so that's a great plan. All right, a little bit about how we do business at Croptimistic. So we work through a partner network. Our technology is scalable across any soil cropping system globally, but it does require local agronomy. So we have about 100 partners globally. Most of them are in North America, and most of them are independent crop consultants and agronomists. That network right now is consulting on about 1 million acres of variable rate annually. And, you know, our system here is usually a good complement to what our partners are already doing. Most of our partners offer a full suite of crop consulting services beyond the SWATmaps ecosystem as well. So that's kind of our business model. For those that are interested, why would you become a partner? And we do have opportunities available to do that. Well, the SWATmap system is a turnkey mapping fertility agronomy solution. So it's a great way to take what we've learned over the last 13 years, and integrate that immediately into your business. It has a full suite of ag tech tools that are growing and will help you grow your business. It's a very profitable business model and has excellent client retention. Additionally, we provide a lot of ongoing support. We have a SWAT Academy, so you'll be fully trained and certified. We have a staff of professionals that support our software and agronomy. And we have a lot of ongoing marketing and research and development innovation that you'll be able to take advantage of as we develop future things, kind of like the SWOT Cam that I introduced to you today. So there's some great benefits to becoming a partner with Croptimistic Technology. So that's kind of the end of my presentation, folks. If you are connected on social media, we have a very active following on Twitter. You can find us at SWATmaps. We have a brand new website. I'd love everybody to go and check it out, www.swatmaps.com. And if you'd like to get a hold of me directly, it's super simple. It's just jack@swatmaps.com. Thank you so much for taking some time out of your day today. And we are very excited about our integration with Climate FieldView.
Thank you, Jack. This was great information. Let's go ahead and answer a few questions here. First one, how would this system be used in an organic operation?
Well, the only difference, I guess, in an organic operation versus, let's call it a traditional fertility operation, is that the type of soil amendments you're using are approved for organic distribution on the field. So you can still grab the field information, you can still create the zones, you can still group those zones together, soil sample, and understand the absolute fertility level of those zones. Now, as the local agronomist, you're going to amend those zones with, treatments that are approved for organic applications, and that's really the only difference I see. The soil's still going to be the same. We can still test the soil. You're just going to use different treatments that fit into your organic cropping system.
Absolutely, that certainly makes sense. Other questions that have come in, which soil labs do you work with in the U.S., and what area do you cover in the U.S.? Okay, so our top 3 soil labs that we work with across North America would be A&L Labs, AgVise, and Next Level Ags. But we can take in soil lab information from virtually any soil lab out there. We just need a CSV file, and it's pretty easy to import into SWOT records. Our coverage in North America is all the way from Texas, basically up to the northern parts of the growing regions in Alberta, Canada, and the Peace River region up there. So we're covering a wide swath in North America. We also have some coverage in Latin America, in South Africa, and in Europe. So, but by and large, we're a North American centric company at the moment. Excellent. And when folks are working with their partners, both in the U.S. and Canada, what are some ballpark prices that growers are paying for a SWOT map through their partner?
Well, we don't dictate how our partners conduct their agronomy business. So my recommendation is, if you'd like me to point you in the direction of some partners so that you can find out what local pricing is with your local partner, just send me an email and I'll make that connection for you, and you should be able to discover pretty easily what something like this would cost you, what your investment would be.
And Jack, you said that you usually work with partners. Do you ever go direct to a farmer?
Yeah, we do have a lot of growers that that have significant acres on their own, and it justifies them being consultants to themselves, if you will. So we do have that model in our partner network, and we have several examples of growers doing that. So we do work direct with farmers, and especially if you're in an area where there isn't a partner kind of conveniently located, we'll work to get your field SWOT mapped and get you some agronomy to help you create those zones and create that variable rate fertility plan.
Excellent, thank you. When the SWOT box is attached to different pieces of equipment, what is the swath width when the SWOT box, that's a tongue twister, goes through the field? So I saw that there were multiple SWOT boxes attached to some of the equipment that you showed. So when does it warrant multiple boxes, and how wide is that?
Yeah, so we recommend kind of a maximum swath width of around 80 feet. And we recommend a maximum collection speed of around 35 miles per hour. So that's moving pretty fast in the field. Hopefully the field conditions are good enough to do that. But if you maintain let's say a maximum swath width of 80 feet and a maximum speed of 35 mile an hour, we're still getting plenty of points mapped in the field to create that high resolution soil zone map that we are proud of. So that's our maximum. Anything less than that is great. I mean, if you want to map at 40 feet or 60 feet, that just means we're going to get higher resolution. That's all.
Excellent. I'm going back to your coverage area. Is there any use of this in the Mississippi Delta or any other parts of the South yet, Southern U.S.?
Yes. We have partners in Texas. I realize that's maybe a little further west from you, but I would consider that the South. So the answer is yes.
Perfect. Okay, folks, I don't see any more questions at this point. I'm going to turn it over to Scott for a closing. And then if you think of any questions during that time, get those sent in and we'll certainly get them presented to Jack. So Scott, all yours.
Yeah, thanks, Mindy, for moderating, and thanks to Jack for the great presentation this morning. I'll just make a few comments here. Another thank you to the audience for joining this morning. I hope you could get some insight into some of the things that Croptimistic can do through their software, data analysis, and their SWOT map technology, as well as how there are some really great opportunities and options to connect and utilize data that's being collected to both make decisions and to help connect those decisions to agronomic practices out there on your fields. As a reminder, please don't hesitate to reach out to us on the climate team for all things FieldView, as well as the Croptimistic team with any questions on their product or their offerings. Thanks again for your time. I appreciate you jumping on this morning, and have a great rest of the day.
Perfect, thank you. I don't see any more questions, so we can go ahead and close things out.
Thank you, folks. Have a great day.
Thanks, Jack. You did a great job once again. We appreciate your knowledge and you sharing that information with all of us.